All right, let's talk about Chapter 10, which is Information Systems Development. This is a rather lengthy chapter. It's going to take us a while to get through the material, so bear with me. I'll try to go as quickly as I can. Very critical unit, though. I don't care whether you're not MIS majors, okay? You are going to encounter this area in your lives somehow, whether you're an end user or you're a leader and you get engaged, okay? I can tell you that people at UCR, when UC Path went into the development phase, there are probably plenty of people at UCR in various departments who said, this doesn't have anything to do with me, call me when the system's done. The reality is you need to be involved early, no matter what your role. So I'll talk about a few different areas today. So the first I'm going to talk about is the agile method of project management. Then I'm going to talk about the waterfall method, or the systems development lifecycle, also known as the software development lifecycle, or SDLC. And then we'll talk about emerging trends. Okay. So agile, think of it like a race car. This gives us a very early and continuous delivery of software. By the way, it doesn't have to just be software. You can use agile for any type of project. Okay. You don't have to use this just for software. It's used in manufacturing and all sorts of other places. Key thing is you do this rapidly, you iterate, you have very small timelines of when you do the work. So for example, most agile projects operate on what's called a 2-week sprint. Sprints can be different lengths, but the general one that you see most of the time is a 2-week sprint. What that means is you start planning at the beginning of the first week, you work the first week, you work the second week, you wrap up at the end of the second week. You do a retrospective of what did you complete, what went well, what didn't go well, what would you change, and then you go back to planning for the next cycle. Okay. This is really a great model for when things are going to change regularly. So this is not a great model. Let me start with where it's not a great model. Agile's not a great model for building an airplane. Once you lock in the requirements of the 787, they're not going to change much. And if they do, you just do a change order later on, right? It's too complex to go and change something that large all the time. Okay. Agile's really great for software, and it's really great for things where you're going to get requirements all the time, or you may not know. So startups use Agile a lot because you don't know what you don't know. If you're in a new area that no one's done before, you don't know what the customer needs or wants. So it's better for you to go and do little pieces until you get what the customer actually wants, than to go and plan something out and then find out the customer doesn't want it. If you get a chance to take BUS101 Systems Analysis and Design, and you get a chance to talk about product management, my hope is that Professor Rich will actually have, there's a book, an online book about a guy who had a startup, and they went the approach of trying to plan it out for 6 months and building it for 6 months. They launched and no customers, absolutely none, used the platform. And then they went to their target customers and said, why aren't you using the platform? They said, it sucks. It's not what we wanted. You built us a car and I wanted a tank. Okay? So this is why Agile's very helpful. With Agile, you also have the developers, the product team, the business teams working collaboratively daily. Let me explain product actually real quick. I mentioned product management. In some organizations, the engineering department is responsible for what your product looks like. Other organizations, the sales organization is responsible for what your product looks like. In other organizations, the product team is responsible for what that product team looks like, and they sit in the middle. Okay? So Apple is a very product-driven company. They go out, they come up with an idea, they design it, they come up with that product, and they figure out what the target customer wants, they figure out what they want to build, then they go to engineering and say, hey, go build this. Other companies are more engineering focused. So Google's an engineering driven company. So the engineers would just kind of go out and say, hey, you know, I really think people want a better email system. And so they go out and build an email system. Then they launch it. And then customers either use it or they don't use it. So, you know, look at the different Google social media things that have come out, right? Each a failure. They're an engineering-driven culture. And then you have cultures that are very customer-driven. So the customer defines everything that happens with your product. And so I've worked for a company previously, they're no longer in business, but I worked for a company that did this, where the customer said jump, and we jumped. We didn't ask how high, we just jumped. And we built whatever the customer wanted. And the problem with that is, unless the customer's paying for it, there's no guarantee that it's actually going to be something that you can sell. So many times we built software for customers that they said they wanted, and then they actually didn't have the money to buy it. So we'd waste a lot of time on that. That, by the way, that boils down to a management issue at the senior level, like the executives, the CEO level. Right? With Agile, projects form around individuals as opposed to individuals forming around projects. Okay? So there's no formal project manager in the Agile method. There's a focus on excellence, so we want, and continuous improvement. So we want to improve. So every time we have a retrospective at the end of every single sprint, whether it's 1 week, 2 weeks, a month, whatever it is, we have a retrospective where we talk about what went wrong and what can we improve. And you will not do better if you just think everything was amazing the first time around, or the second time, or the third time. You can be 50 sprints in and still be learning new things and improving. Okay? So with Agile, we have a few key components. We have a Scrum. And so our Scrum team is a small group of people. The number of people varies, but let's just say 4 to 7 or 8 people on a Scrum team. And they work together and they plan out the sprints. They have, they do work together. They do demos together. They work through their issues, and they work on a specific area. The scope of that area depends on the size of the company, obviously. So, to give you an example, the company I work for is relatively large as far as smaller companies go. So we have around 1,000 people working for us, okay? And our engineering team is, gosh, probably almost 400 people now, I don't know. We have smaller teams that work on specific things. So our biggest products, a team works on maybe a specific set of features, okay? Our smaller products, we might have a Scrum team that works on that entire product. It just really depends on the size of the product. And it changes over time. So our biggest product, initially had a few people on a Scrum team working on the whole thing. But as the product grew and there were more and more features and more customer requests, it expanded the size of the team, which meant we had a bunch of Scrum teams. And now you're gonna probably say, well, how do those Scrum teams organize with each other? They have what's called a Scrum of Scrum. So the Scrum Masters, who effectively lead these teams, they're just regular people on the team, but they take care of leading the team in the Scrum. They get together and they do a Scrum of Scrums, where they get together and they share what everybody on their Scrum team is working on. Then there might be, depending on how large teams are, there might be another layer above another Scrum of Scrums of those leads. And then eventually that high-level work product progress gets reported up to the executives in charge of the engineering organization. Okay. Now, within that sprint, generally I said 2 weeks, but that can vary. You do planning. You do that at the beginning of the week, or beginning of sprint, excuse me. Then you do daily stand-up meetings every day. And they call it stand-up meeting because the idea is nobody sits down. Now, that's a little easier said than done when you're all remote, but these stand-up meetings are like 5 to 15 minutes max, okay? So they're literally someone talking for less than a minute, okay? Usually it is, what did you do yesterday? What are you gonna do today? And do you have any blockers? That's really the 3 questions everybody's expected to answer in the stand-up. So if you get called into stand-up at your first job, you don't know what the hell it is, it's probably just, what did you do yesterday? What are you gonna do today? Did you have any issues you need to report? Because if we report the issues daily, then the Scrum Master can make sure we get the right person involved to help you. We don't wait till the end, find out there's a problem and you miss your deliverable, okay? So this can be very useful in your work environment, even if you're not in development. Now, at the end of your sprint, you do a retrospective. During that retrospective, you look back at the sprint and you say, what went well, what didn't go well? And here's an example from a real sprint from a previous version of this class, okay, where you did have teams in another class. Let's say you have a team of 5 and you're trying to work on a project together. And Johnny says, I'm gonna get these 5 things done this week. And Sally says, I'm gonna get these 10 things done this week, okay? And at the end of the week, Johnny gets 3 things done and Sally gets 20 things done. Obviously, Johnny overestimated and Sally underestimated their work. They could get better at estimation. That's an improvement they could make. They could also work at how could they divide the work up more appropriately. Maybe Johnny was working on 3 giant things and Sally was working on 20 little tiny things, right? So it allows the team to self-manage their work better. There's no manager sitting here dividing up the work generally on a Scrum team. Usually there's a manager, and the manager is responsible for people issues, but sometimes the manager is just doing as much work as the team. So they're just, they're collaborating with the team as well. So we've got to think about that sort of thing in those retrospective meetings. Okay? Another thing is, how is the team working together? Are there communication issues? Are there conflicts? Are there things that can be worked through? You want to put them out on the table. You don't want to hide these things, pretend they'll go away, because they never do go away. Okay? Now, you can use different types of tooling for Agile. So Jira is one example. It's not cheap, but it is a product that's used across the board, pretty standard across a lot of organizations for doing Agile management of teams. But there's a number of other options. So ClickUp, Trello, and Asana are all project management tools that can be used for Agile projects. Okay? And then the last one is Microsoft Azure DevOps. This is more for people who use the Microsoft stack. This is a tool that they have available. Now, let's move on to Waterfall and SDLC. This is known as the Waterfall method. And normally I would say, can anybody tell me why? Okay? But because you can't, it's because you have very well-defined phases that are performed in a sequence. So you do planning, the water flows over the rocks to the next level of the waterfall. Now you're in requirements. Now the water flows down to the next layer of rocks and you're in design. Flows again down to implementation. Flows again down to maintenance. It's very difficult to go back up to the top of that waterfall. Okay, if you've got some sort of levitation device, A, I want to know about it because I want one myself. And B, it's pretty difficult to do that, right? So it's very difficult to go back on a project where you've done all this planning ahead of time. It's very disruptive. So with Waterfall, you don't do things on a 2-week sprint. You do them on a much longer term basis. And then if you need to make a change, you have to do it as part of a new project later on. Okay? There's an example in the book on page 220 that you might want to look at. With Waterfall, you have a formal project management structure and a formal project manager who compiles various documentation. So like I said, Boeing uses the Waterfall method for building airplanes. The government uses it for modernizing, aircraft carriers or whatever it might be. They use Waterfall method. They cannot afford to use the Agile method. They aren't able to move that quickly. Now, there might be teams within those agencies and entities that do Agile for smaller things, but they're certainly not doing it on a grand scale. With Waterfall, we use something called a Gantt chart, and I will try to show you an example if I don't have one in the slides. Okay? Try to show you an example in the demo, and you can use different tooling for that. So you can use Microsoft Project and Smartsheet are some examples. Smartsheet costs money, but it's cloud-based. Microsoft Project, you have to install something, only you have access to it. You have to share the file, which means other people then have to install Project. It's kind of a really expensive approach to go. A lot of organizations have shifted away from that model to go to more of a cloud-based system. Okay. Planning. So that's the first phase. We have to define what the problem is that the organization is trying to solve. If we can't agree on what the problem is we're trying to solve and articulate that well, we will fail. And we know that from the very beginning, that if we cannot articulate our problem, we will fail. All right. Second thing is, let's assess our current and future needs. So why do we want to develop this system? Who are going to be the users? Is it a new system? Can we upgrade an existing system? Which departments are going to use the system? When will we think it be finished? What capabilities does the system need to have? And then we form a task force of internal users, and depending on the situation, perhaps external users as well. We don't generally invite external users, for things like our ERP system. We're not going to invite external people, right? Maybe a supplier or something like that, but certainly not customers. We will, however, maybe invite customers to give feedback on a new web application that we're going to develop. Okay. As part of the planning process, we assess the feasibility. Is it economically feasible? Is this thing going to cost us $1 billion and we're only going to get $10 million of value out of it? Then it's economically infeasible. The technical feasibility, if we're trying to build a rocket that goes to Mars, Today, the technical feasibility of that is not there. So why would we even begin a process like that if we don't have the technical feasibility to do that? Okay. Can we operationally have that feasibility? Is the schedule feasible? You know, if we've got something that's going to take us a year and our schedule means we have to have it in a month, we're going to fail. So there's no point. Okay? It's not feasible. And then the legal feasibility. Is this something we can legally do anyways? Next, we move into requirements phase. So on the requirements phase, we have different requirement types. Okay? The first is functional requirements. This is the functionality of the system. Okay? So I want to be able to enter your grades into a system in one place and have it automatically feed to another. That's a functional requirement. Okay? A non-functional requirement is something that doesn't affect the functionality. So a good example is I want to have 24/7 support. Okay? I want the system to be available 24 hours a day, 7 days a week. That doesn't affect the functionality, but it is important. That's a non-functional requirement. So how do we gather and compile requirements? Okay? We go and do a number of things. Okay? First thing we can do is a user interview. So I can go up to, my dog's laying here, so I can go up to her and I can say, I know you don't like your food. So what flavor of food would you like to eat? Okay? And she'll tell me whatever you're eating, that would be fine. Okay? That's what we do with a user interview. We want to understand what the user wants. Okay? Another way is to compile a survey. Now, I'm not going to be able to send my dog a survey because she doesn't have opposable thumbs. Okay? And she can't read either. She's illiterate. But I could send a survey to someone and ask them to fill it out. But it's not interactive. So this is why surveys are not the best way to do gathering requirements, because I can send out a survey and ask some pointed questions. What if I didn't think about something? What if the only way I can think of it is if I start having a conversation with the user? That's why user interviews are a really great way. Okay? Another way is to have a meeting. So you get everybody together in a particular functional area and you do a real-time requirements definition meeting. Okay? You have a whiteboard, markers, you can do this electronically as well. Okay? Sticky notes, pens, you give some sort of currency for prioritization. When I do this in the classroom, I give everybody Monopoly money. Okay? And so you can only spend what you have. You don't have a credit card, so you have to take that money and spend it wisely on what's important to you in terms of requirements. And it really forces people to think about what's really important to them. Okay? This works well if you've got multiple people involved and you need buy-in from different departments. It also works well if you've got tight deadlines and you have to move quickly. Okay? You just pull everybody together. Now, once we have requirements, we have to categorize them. Are they functional or non-functional? And if they're functional, maybe we define them by component or product area. Now, how you categorize is entirely up to you. This is just an example. So if you were categorizing requirements, you would categorize them by however you felt was the most logical way. So for an HR system, this might be requirements for recruitment, hiring, termination, performance management, payroll, employment changes, etc. Okay. For non-functional, it could be security, service level, support, reliability, etc. Now, after we have compiled the requirements and categorized them, we have to prioritize them. And that's where that currency comes in. If money was infinite and time was infinite, then we wouldn't need to prioritize anything. Okay, we could do everything. So this is that old saying of you've got to boil a pot of water before you can boil the ocean. Okay? So let's boil a pot of water and let's choose what's going to be in that pot of water, and then let's figure out how to boil the ocean later. Okay? Another example using the rocket, let's figure out how to fly back to the moon again, as opposed to figuring out how to fly to Mars. Okay? Now, one method of doing requirements, and this is used a lot with product management, is user stories. So we have a user write up user stories of their requirements. And so we're asking them to provide just enough information to allow us to estimate the effort needed to implement. And we have to really have a conversation with customers. And so we can think of stories as the smallest work unit of a project. So it's generally one task that can be completed in a sprint. So we generally take, if it's longer than that, it's called an epic, and then that's broken down into multiple stories. Okay. So here's an example, and each of these in this example is a story. So students can purchase monthly parking passes online is one story. Parking passes can be paid via PayPal is another story. Each of those are separate requirements. Each of those are things that at this point we think can be estimated as a unit of work for one sprint. But can purchase a monthly pass online, as we dig into it deeper, we might discover that's actually multiple stories we have to think about further how to break those down. Okay. Who writes these stories? First of all, stakeholders could do them, domain experts. So if you're the expert on how to do payroll, then you could do a story. Also, end users can write them. So you can use index cards, Jira, sticky notes, a project management tool, however you think it's most effective. So when we're normally on campus, I have students go out and do this at the hub. Okay? And they go out and have to ask people, you know, if you were to completely rebuild iLearn, what would it look like? And ask people's input. Or if you were to completely build a brand new residence hall, what's the most important thing that you would build into that residence hall? That sort of thing. Okay. User stories get a priority, and you can use a form of currency to spend on it, or you can also use voting, where everybody gets 5 votes to vote on. Of the 100 items, they get 5 votes each, okay? And that helps you to prioritize. We can have informally written user stories like the ones I gave you previously, or you can have formal where you basically get really formal in your language. So informal is students can purchase a parking pass. A formal way of writing that would be, as a student, I want to purchase a parking pass so that I can drive to school. Okay. We start off with, as a student, okay, that's the person. I want to purchase a parking pass. Okay. Why? So I can drive to school. Okay. Now, during the planning phase, we can prioritize the stories, and the developers will estimate the level of effort to implement that. An epic, as I mentioned, is just a large story where we haven't figured out the details yet, and once we figure them out, we'll break the epic up into multiple stories. So epics are generally a lower priority because we haven't fleshed out the details. So here's an example of a product story lifecycle, and you can take a look at this diagram. But effectively what happens is we have a roadmap of what our product should look like. We get ideas from our stakeholders. We create stories. We have conversations with stakeholders. That feeds into us burning down or completing the stories. That means we actually are doing the work to complete what they're asking for. We then create more stories. Those stories get burned down, we end up releasing the product. Once the product is released, it goes into an operations phase, depending on what it is. Then we also get new stories, which are new requirements. We go back to the beginning, and we go through and we burn down those stories. It's an endless cycle as long as we're continuing to develop that product. So there are some products that we use today that have been around for a very long time. Microsoft Office is a great example. Microsoft Windows, Mac OS, these are all great examples. These are not new products. New enhancements go in, they get feedback from customers, they find ideas internally, those roll in, and eventually they roll out into a new version of these products for us. All right. Themes are just another name for category. So we can group categories of stories together. Once we've written a story, we go to what's called a use case. And a use case, we want to make sure that we write up specifically how we do something for a story. And when we do a use case, we're really focused on the minimum viable product right now. Okay? We'll iterate our product and make it better over time, but we're really thinking about what is our minimum viable product to make our customer happy. Okay? So here's an example of a use case for the user story, which is enrolling in a class. The terminology, this is a British company, I think, that did this. So seminar is what they call regular classes in other countries. Okay? So students want to enroll in a class. Okay? And their course of action, their use case is step 1, they're going to input their name and student number. Step 2, system's going to verify they're a student and eligible to enroll. Okay? If not, then the use case ends. The system's then going to display a list of available classes. The student's then going to choose which class or decides not to enroll. Then the system's going to verify if the student's eligible to enroll. If not, you're going to be asked to choose another class. Okay? And so on and so forth. Each of these is a step in the use case. What this is useful for is this gives a developer the steps needed to write the code. It doesn't tell them how to write the code, but the developer can now take this and take actual action on it. Okay? So it's very important that your user stories be detailed enough to be actionable, and then the specific steps are referenced in a use case. Okay? Now, the next step after that is you do a wireframe. Okay, and so a wireframe is just, and you don't always do wireframes, but a lot of times they're helpful. This is just your sketch on a napkin, okay? So you've got an idea for Facebook. So you sketch it out on a napkin and you tell someone else, this is what I want to build, okay? That's what a wireframe is. It's just basically a back of a napkin type sketch, hand drawn, whatever. Now you move into the design phase. Okay? As part of the design phase, you do data flows. Okay? You can have mock-ups and prototypes, and there's an example to mock-ups and how you do them. Okay? This is more detailed. A mock-up is like a full color version of what you want the website to look for or the application to look like. A prototype is actually functional, meaning I can click a button and it does something. It's not the real live site, don't get me wrong, right? It's just, I click a button and it moves to the next page. So it could be as simple as a PowerPoint of the website, what it looks like. And I click a button and it makes a PowerPoint move to the next page. Okay. After that, we have implementation. So during the implementation, we might acquire technology. We might hire people. We might train people. We might do additional planning and designing. We do coding. So we develop the software for making software. We do testing. We validate security and we protect the data. Now, as part of implementation, we can have different types. So parallel conversion is when we have the old system and the new system and they run simultaneously. And an example of this is I was at a gas station once and I was purchasing something and I was checking out. And the guy was standing in front of two cash registers. He scans my items on the first one, then he scans them on the second one. He only swipes my credit card for the first one. And he had to do that because they were changing cash registers. And so they were running both in parallel, and they wanted to make sure that the transactions were scanning accurately. That's a parallel conversion. Then you've got a phased in, phased out, where you phase in new modules to the system as the new system comes online, and then the old ones are retired. Okay. So an example of this is a lot of companies, when they're redoing their ERP system, they will do their payroll module, and they'll turn off the old one. But they'll still have their old accounts payable module. And then later on, they'll bring that one online and they'll retire the old one. Okay? So that's a phased in, phased out. The third one is a plunge or a direct cutover. This is basically where we say, we're gonna cut over on this date and you're screwed if it doesn't work. Okay? You shut down the old system, you move the data, and then you turn on the new system. That's how UC Path did it for each campus. Was an old system went down, the new system went live. Okay? Pilot conversion is where we limit the introduction to a small division or department. So we're going to go ahead and convert the entire New Zealand manufacturing division to our new payroll system. But we're not going to convert anybody else yet. Okay? We're going to do a small pilot. Now, another aspect with these systems is requests for proposals or RFPs. And we can use these a lot for government procurement. So anytime we buy something in the government, we have to do an RFP process. Okay? Sometimes you'll see larger organizations use this process. I did a help with a bid with a large technology company that I totally wouldn't expect to do an RFP, and they did. Okay. The next phase is maintenance. So now the system's turned on, it's operational, people are using it. People are going to want to improve the system. There are going to be bugs in the system. There are going to be new features that we want, okay? And this is also where we analyze the performance data and we make any necessary changes. And then lastly, let's talk about some emerging trends. And we'll talk about some things related to emerging technologies at the end of the course. Okay? Service-oriented architecture and microservices. This is big right now. We are building services that are specific to one set of functionality. The old way of doing this was called a monolithic application. So we build one mammoth application with everything in it, and then we'd release it. And this is why we had to release under waterfall, because it took us years to build it. And now if we want to upgrade it, we have to upgrade the whole damn thing. Okay? With a microservice or an SOA, service-oriented architecture, we don't have to do that. We can have a service to send emails to customers. We can have a service to accept payments. We can have a service to print off invoices. Okay? Each of those are a service. So each one of those can be maintained independently, which means we can rapidly deploy features for customers. Okay? Another trend is rapid application development, where we're just rapidly developing things and we're moving at the speed of light. Okay? Another thing is extreme programming or pair programming. This is where we have two developers sitting at the same computer talking through as they write the code. And one is talking and commenting on what they think about the code while the other one's writing, and then they switch off. Okay? Now this means for everything you're doing, you need two developers. But this can be beneficial because you might end up with higher quality code. You might have to do less testing of it. You might end up with learning things that maybe the first person hadn't thought of. I haven't seen this one take off a whole lot. I've seen it happen at a few companies. I kind of think it's a little weird. And in COVID, I don't know how that's going to fit with COVID because you can't really sit next to each other anymore. And then Agile, I already mentioned. Kanban is the last one here. Kanban boards are used more from a business management standpoint. So Toyota invented this. And they invented it for their factories to be more efficient. So the idea of Kanban is you have a board and you have different cards and you move them through different stages of the board. So for example, if I had a to-do list sitting here, I might have a to-do column on a whiteboard, a doing column on a whiteboard, and a done column. And so as I start working on things, I move those cards in the column on the whiteboard from to do to doing. And then once I finish them, I move them to done. And then at the end of the week, I figure out how many things I did that week. And that's the report that I give to my leadership. Okay. So that's Kanban. And I'll mention it. I'll do a demonstration of it, but it's not something you're required to do in this particular class. That's it for this unit. And I will go ahead and record some demos here in the next couple of days to post for you.